Hello everyone, I hope you are doing well. So in this video, we're going to discuss Leetcode problem of the day, and today's problem is arithmetic subarrays, and it is going to be a medium level problem. And after a very long time, I see a very short title for the Leetcode problem of the day. That means the problem name is very small, right? So let us just quickly see what the problem says. It says that we have been given a sequence of numbers, right? And we have also been given two vectors L and R, right? So for each operation, what we will have to do for each indexes in this LNR vector, we have to tell whether the integers in this nums array in the range L to R, that means L0, R0, then L1, R1 are an arithmetic sequence or not. So what is an arithmetic sequence? As the name suggests, it should be an arithmetic progression. That means the difference between the adjacent two elements should be constant, right? And we are allowed to rearrange the elements in any way we want. So for example, if I take 0 and 2, so 0 index is this one and 2 index is this one, I can rearrange the elements in this particular range, and I have to tell if by rearranging I can form an arithmetic sequence or not, right? So arithmetic progression is very simple. You see that if there, let's say this is A1 and this is A2, the difference between A2 and A1, let's say it is going to be dx. Now the difference between A3 and A2 should also be dx, and the difference between A4 and A3 should also be dx, right? This is the property that we have to maintain, and we have to tell whether there is a way to rearrange the elements, and it is possible to do this particular thing at the same time or not, right? So if you want the difference to be constant, now there is a one very important observation that you would have seen already, that it is going to be an arithmetic progression. So either the numbers are increasing in a manner or the numbers are decreasing in a manner, right? So the difference can be dx every time, right? Or it can be some negative value minus dx every time, right? So one of these has to be followed. Now what you can do is, I went through it constraints, and according to it I formed my solution. I saw that it is possible for every range L and R to sort the elements, so that it is this particular case. You can also choose this particular case, but it was convenient to choose this particular case only, right? So I know I can make all the elements in the range to this particular case and just simply check by making a for loop whether the dx is constant or not, right? So how do we estimate the time complexity? We know that the size of the L and R vectors is at max 500, right? At max it is 500, and for each element, right, for each of these ranges, the maximum number of elements in our nums array is also 500, right? So there will be 500 queries, right? For each of the queries, we'll have to sort the 500. Let's say for each of the queries are 0 500 0 500 0 500, so we will have to sort an array of 500 size, right? So it takes 500 into log 500, which is roughly 10, right? So this is log base 2, right? So this is the number of queries that we have. This is the time required for sorting, and for checking whether this works or not, it is also going to take 500, right? So this is like this. So plus 500. So to calculate the rough complexity, it is going to be 500 into 500 into 10, right? 10 because of this, and I'm just ignoring this 500 because this is the bigger term for calculating the worst case complexity, right? So this is 25 4 zeros and 1 0 extra, right? So these are 6, 2 into 10 to the power 6 approximately. So this was roughly the complexity that I was getting. So it is very easy to apply brute force and just sort all of the ranges whatever we get, and just check whether we can make the answer or not. So this is exactly what I have done. I have initialized a boolean vector of answer, and I am just going through all the values in the L and R vectors. So first of all, I will have to check whether it is an array of size at least 2, right? So they have mentioned this particular statement that I believe there was somewhere in this particular, here it is. It says that there should be at least 2 elements, right? So I am checking whether this range has at least 2 elements or not, and if it has, I am initializing my answer of I with 1. I am creating a copy vector of nums because I don't want to alter these array elements. So I am creating a copy array, and I am sorting all the elements in this particular range, starting from Li going till Ri. Since I also want to include Ri, I am adding 1 here, right? Now I am calculating my dx, so I am calculating it as the first element minus the zeroth element. right? Now starting from the second element, I can check whether copy of j minus 1 is not equals to dx. Then I can set my answer of I is 0 and break, right? If all of the values are equal to dx, then my answer of I will still remain 1. So that is it for this particular video, and if you do this, then your code will work. And we figured out mathematically that according to our constraints, we can form the solution. If it was not possible, we could have thought of some other approaches as well, but since it is well within the constraints, we can use this particular approach of brute force, right? So that was it for this particular video. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach much more people like you who want to keep solving new problems. So that is it for today. Till the next video drops, keep coding, stay safe, bye bye.